This rocket costs $2 billion every time it flies. It is fully expendable. It uses engines from the 1980s. And by most engineering standards, it is a bad rocket. So why does it exist? The answer is that this is not a rocket. It is a workforce with a rocket on top. The case against SLS is well documented and largely correct. It is expensive, it is slow, it is not reusable. It is built from refurbished, decades-old hardware. It is not cost competitive with commercial alternatives that exist today and will be substantially less competitive with alternatives that are coming. The orange color of the core stage is not a design choice. It is the color of the spray-on foam insulation that has been used on shuttle-derived hardware since the 1980s. The same insulation, on the same tank tooling, made in the same factory in Louisiana, by the same workforce that built the shuttle external tanks. The visual continuity is not coincidental. It is the most important fact about the program. These criticisms are accurate. People who say these things about SLS are not wrong. So why does the program exist? Why has it survived 4 administrations, multiple budget battles, and the rise of commercial alternatives that do the same job for a fraction of the cost? The answer is the reframing this whole video is built on. SLS is not a rocket. It is a workforce with a rocket on top. When the Space Shuttle program ended in 2011, it employed tens of thousands of people across a network of facilities that had been built up over 4 decades. Marshall Space Flight Center in Alabama, Michoud Assembly Facility in Louisiana, Stennis Space Center in Mississippi, Kennedy Space Center in Florida, a vast contractor network including Boeing, Northrop Grumman, Aerojet Rocketdyne, and dozens of suppliers across most U.S. states. The end of the shuttle program threatened to dissolve this network. Once the workforce disperses and the supply chain shut down, reconstituting them is extremely difficult. Specialized welding skills, friction stir welding capabilities, large solid rocket motor casting expertise, the ability to manufacture and integrate human-rated launch vehicles at scale. All of these exist because they're continuously practiced. Stop practicing them for a decade, and the people retire, the equipment is repurposed, the institutional knowledge is lost. Here is the part that gets glossed over in most coverage of SLS. The senators and representatives whose districts host the major SLS facilities were not randomly distributed across Congress in 2010. They held specific positions on the committees that authorize and fund NASA. Richard Shelby of Alabama, whose state houses Marshall and a major Boeing facility, was ranking member of the Senate Appropriations Subcommittee that funds NASA. Bill Nelson of Florida, whose state houses Kennedy, chaired the Senate Subcommittee on Science and Space, the subcommittee with direct jurisdiction over NASA authorization. Kay Bailey Hutchison of Texas, whose state houses Johnson Space Center, was the senior Republican on the Commerce Committee, which also has NASA jurisdiction. Orrin Hatch of Utah, whose state houses the Northrop Grumman solid rocket motor facility, was the senior senator from a state critical to the solid rocket booster supply chain. The 2010 NASA Authorization Act, which created SLS, was written by these senators and their staffs. The law included specific language directing NASA to use shuttle-derived hardware and to maintain the existing contractor workforce, the same engines, the same boosters, the same tank manufacturing, the same workforce. This was not an engineering decision made by NASA. It was a policy decision made by Congress, written by senators whose states would directly benefit from the policy, and NASA was directed to execute it. The program had 3 goals, none of them about producing a good rocket-on-rocket criteria: preserve the shuttle industrial base, distribute federal aerospace jobs to politically important states and districts, maintain sovereign U.S. capability for human spaceflight under direct government control. On all 3 of these criteria, SLS has succeeded. The industrial base was preserved, the jobs were maintained, the sovereign capability exists. The rocket flies. It works. And it has flown a crewed-capable mission around the moon. If you measure SLS on the criteria the program was actually designed to satisfy, it is a success. If you measure it on the criteria most engineers and most space enthusiasts apply to rockets, it is a failure. Both evaluations are correct. They are measuring different things. This is the reframing. SLS is not a bad rocket pretending to be a good one. It is a workforce with a rocket on top. The rocket is the visible output. The workforce is the actual purpose. Once you see SLS as a workforce with a rocket on top, every decision about the program that seems strange suddenly makes sense. Why use refurbished shuttle engines instead of designing new ones? Because new engine development would have meant new contractor relationships, new manufacturing sites, possibly the loss of Aerojet Rocketdyne as the engine supplier. Using existing engines, even at the cost of throwing them in the ocean after one use, preserved the existing supply chain. Why solid rocket boosters instead of liquid-fueled alternatives? Because Northrop Grumman, which inherited the shuttle solid rocket motor business from Thiokol, has its production facility in Utah, and the Utah delegation was a consistent and influential supporter of the program. Solid boosters are not the engineering optimal choice for SLS, they are the political optimal choice. Why expendable rather than reusable? This is the most counterintuitive part. Reusability would have meant lower flight rates, fewer engines built per year, less manufacturing employment, and a fundamentally different industrial structure. The shuttle was reusable and it employed tens of thousands of people because reusability turned out to require enormous refurbishment workforces. SLS is expendable because expendability, paradoxically, may sustain more aerospace employment by requiring new hardware for each flight. Every decision that seems backward on rocket criteria has a clear logic on workforce criteria. The program is internally consistent once you understand what it is actually trying to do. The criticism that SLS is poorly designed misses the point. SLS is designed correctly for its actual purpose. The disagreement is about whether that purpose is the right one. If SLS is a workforce program, the right way to evaluate it is on workforce program criteria. Does it preserve capabilities that would otherwise be lost? Does it sustain employment in strategically important sectors? Does it position the country well for the future of the industry it operates in? On capability preservation, SLS has succeeded. The shuttle-derived industrial base would have substantially dissolved without the program. On employment sustainment, it has also succeeded. The program directly and indirectly supports tens of thousands of jobs across a geographically distributed contractor network. On future positioning, the answer is harder, and this is where the case for SLS as workforce policy gets weaker. The commercial launch industry is developing different capabilities. High flight rate operations, rapid reusability, large-scale stainless steel manufacturing, methane-fueled engine production at scale, vertical integration of design, manufacturing, and operations. These capabilities will define the next generation of U.S. aerospace capacity, and SLS does not preserve any of them. The industrial base SLS sustains is the industrial base of yesterday, not tomorrow. This is the strongest argument against SLS as workforce policy. Not that workforce policy is illegitimate, not that capability preservation is wrong, but that the specific capabilities being preserved are the ones that the rest of the launch industry has moved past. SLS may be successful workforce policy for an industry that no longer exists. The honest answer to whether SLS is good at what it actually does is it depends on what you think the future of the U.S. aerospace industry should look like. If you think the future is commercial, reusable, high flight rate launch, SLS is preserving the wrong workforce. If you think sovereign government-controlled heavy lift capability is strategically essential regardless of commercial alternatives, SLS is preserving exactly the right one. The disagreement is fundamentally about strategic priorities, not about engineering. So is SLS any good? The question that seemed simple at the start of this video does not have a simple answer. As a rocket, SLS is not good by the standards engineers use to evaluate rockets. As workforce preservation aimed at maintaining the shuttle industrial base, it is largely successful. As a political program, it is extraordinarily successful, having survived 4 administrations and weathered budget crises and external criticism. As strategic positioning of the U.S. aerospace industry for the next half-century, it is questionable because the workforce it preserves is increasingly disconnected from where the industry is going. All four of these evaluations are correct. The reason the SLS debate generates so much heat is that participants choose which evaluation to emphasize and then argue past each other. Critics emphasize the rocket evaluation. Defenders emphasize the workforce and political evaluations. Both sides have valid points. Neither side is engaging with the full picture. The orange color of the core stage is the right symbol for the whole program. It is the same insulation on the same tank tooling made by the same workforce that flew on the Space Shuttle. SLS is not a new rocket. It is the Space Shuttle program continuing under a new name, with the orbiter replaced by an expendable upper stage and a capsule. The workforce that built the shuttle for 30 years is the workforce that builds SLS today. That is the point of the program. The orange color of the core stage is the right symbol for the whole program. It is the same insulation on the same tank tooling made by the same workforce that flew on the Space Shuttle. SLS is not a new rocket. It is the Space Shuttle program continuing under a new name, with the orbiter replaced by an expendable upper stage and a capsule. The workforce that built the shuttle for 30 years is the workforce that builds SLS today. That is the point of the program. If you understand SLS as the shuttle workforce in a new form, the strengths and weaknesses become clearer. The strengths are the strengths of the shuttle workforce: deep institutional knowledge, sustained industrial capability, a workforce that has been building these specific systems for decades, political durability across administrations. The weaknesses are the weaknesses of the shuttle workforce: high cost per flight, limited flight rate, expendable hardware that should not be, technology that is 2 generations behind the cutting edge. The deeper question that SLS forces is one the country has not really answered. What is the federal government's role in space launch in an era when commercial providers can do most launches better and cheaper than the government can? The shuttle was built when there was no meaningful commercial alternative. SLS was built when commercial alternatives were emerging, but not yet proven. By the time SLS retires, commercial alternatives will be dominant. There is a defensible version of the SLS story in which the program bought time. Time for the commercial industry to mature. Time for NASA to develop a new mission architecture. Time for the political system to figure out what comes next. In this version, SLS was never going to be the future of U.S. launch capability. It was a bridge that kept the door open while the future was being built elsewhere. There is also a version in which SLS was a way of protecting the past at the expense of the future. The same money spent on different programs might have accelerated the commercial transition, funded new technologies, or built capabilities that align with where the industry is going. In this version, SLS was a political success and a strategic failure, a program that preserved jobs at the cost of slowing the country's adaptation to a changing industry. The honest answer is probably some combination of both. SLS is not the disaster that its harshest critics describe, and it is not the success that its defenders claim. It is a workforce with a rocket on top. The workforce was preserved. The rocket was built. Whether the workforce should have been preserved and whether the rocket was the right output for that workforce to produce are questions that historians will probably argue about for decades. Is SLS any good? It depends on what you measure. As a rocket, no. As workforce preservation, yes. As a political program, yes. As strategic positioning, probably not. All of these are true at the same time. What SLS is not is a mistake or a fraud or a boondoggle in the ways that some of its critics describe. It is a workforce with a rocket on top. The workforce was preserved, the rocket was built, and the program accomplished what it was actually designed to accomplish. The disagreement about whether that was the right thing to accomplish is a real disagreement, but it is not a disagreement about whether the program succeeded at its own goals. The next question, the one that matters more than whether SLS is good, is what comes after it. The commercial alternatives are emerging. Starship is being tested. New Glenn is operational. The era of government-built, heavy-lift launch vehicles is probably ending. SLS will fly a few more times, and then it will be retired. And the question of what role the federal government plays in launch will have to be answered fresh. SLS is the last of its kind. It is the last workforce preservation program of the Shuttle-era. The workforce it preserved will retire with it, And the next generation of U.S. aerospace capability will be built by a different workforce, in different facilities, under different industrial logic. Understanding SLS as the end of something rather than the failed beginning of something else is probably the closest the question of whether it is any good gets to a useful answer.